All right, here's our station rotation for 9C for the intermediate. We've got a reminder here of, so there's some review material to start off with, naming polynomials by degree and number of terms. Degree 0 is constant, degree 1 is linear. We got that table to help us out. So if we're writing these in standard form and then naming the polynomial and its leading coefficient, in standard form, this is going to be negative 6x to the fourth plus 3. That is a quartic binomial. And the leading coefficient, I'll abbreviate with an LC, is negative 6. This one in standard form will be 6x squared minus 13x minus 5. That is a quadratic trinomial. The standard talked about recognizing when we have quadratic equations or functions, and so this one clearly is not because it's quartic, so on some of these we can notice it that way. The leading coefficient is 6. Pause for a second to sharpen my pencil. All right, this one, standard form, we're going to leave with the negative x cubed plus 2x squared minus 5. That is a cubic trinomial. So not quadratic. Leading coefficient is negative 1. This one in standard form would be negative 4x squared plus 25. This is a quadratic binomial. And the leading coefficient is negative 4. All right, this one is already in standard form. And it is degree 0, so this is a constant. That's kind of all we have to say about that. This one also already in standard form, and this is degree 1, so this is a linear binomial. And the leading coefficient is 6, acting as the slope of that. So there is the review part for the intermediate. Here is the new part, something called the zero product property. Zero product property says that the only way that you can get an answer to a multiplication problem is what this should have said there. Got some things to fix there. Can be 0 is if one of the factors is 0. Remember, factors are the things involved in a multiplication problem, the things that you're actually multiplying together. So, in this case, the things that are multiplying together are x and y. And the only way this can come out to be 0 is either x is equal to 0 or y is equal to 0. One of those two things has to be true, or that product will never be 0. Okay? 0 is unique in this. There's no other number that we can say that if we multiply things together and get that as an answer, then we can lock in what one of those things has to be. So this is why 0 has that special property. So over here, the two things that are being multiplied together, there's an x and there is an x minus 5. I guess I don't need the x minus 5 necessarily in parentheses. And so the only way that this product can be 0 is if the x is 0 or if the x minus 5 is equal to 0. The x minus 5, I now get a linear equation from this, and so I could add 5 to both sides and say the only way this is going to come out to be 0 is if x is 0 or if x is 5. Here, my two things being multiplied together, one is an x plus 2 And so either x plus 2 has to be 0 or x minus 1 has to be 0. And so if I subtract 2 from both sides there, that means either x is negative 2 or adding 1 to both sides here, x is equal to 1. If I put 1 in for both x's, this will come out to be 0. If I put negative 2 in for both x's, it will come out to be 0. Okay. For this one, either x plus 1 is equal to 0 or 2x minus 7 is equal to 0. It's got to be one of those two things. That means that x would have to be negative 1 here if I subtract 1 from both sides, or the 2x equals 7, and then dividing by 2 on both sides, x is equal to 7 halves. Good math people now, we love a good fraction. So as long as if x is negative 1, it'll make this part 0 and this something else, but who cares because it's times 0. If x is 7 halves, it'll make this part 0 and this part will be who cares because it's getting multiplied by 0. Right, so these are the two solutions to this equation. Right, following the pattern now, 3x plus 7 equals 0, or 5x plus 9 equals 0. This would mean 3x would have to be negative 7 when I subtract 7 from both sides. And divide by 3, x is negative 7/3, or subtract 9 from both sides here, 5x is negative 9, divide both sides by 5, and x is negative 9/5. Okay. So these are my answers there. X equals 0 or x equals 5 are my answers there. X is negative 2 or negative 1. X is negative 1 or 7 halves. X is negative 7/3 or negative 9/5. For this one, the things being multiplied together, there's a 3 there. So either 3 is equal to 0, or 4x minus 1 squared means 4x minus 1 times 4x minus 1. So, or 4x minus 1 is 0, or 4x minus 1 is 0. 3 can't ever be 0. There's no variable in there to do that, so that's not going to give me any answers. This one, I add 1 to both sides. I get 4x is 1 and x is 1/4. 4x is equal to 1 and x is 1/4. So those are actually the same, so I can say there's only one value of x that will actually make this thing equal 0. So that's the zero product property. This, incidentally, is going to be one of our ways of finding the x-intercepts of a quadratic. Okay, because if we can take that quadratic and factor it like we did in chapter 8, if we set it equal to 0, which is what we would want to do if we're finding an x-intercept, because x-intercepts are always some number comma 0, so the y part is always 0, okay, then we might be able to find x-intercepts by doing the work this way.